What's up, gangsters? It's time for yet another review, and I think you'll agree this one is pretty cool. If you are one of the 5 people that actually follows my nonsense, you may recall that not too long ago, it's late April of 2016, that I started on a project to build an Aero Phantasma car plane. Now, if you're not familiar with that, that is where basically you take the fuselage of some kind of an aircraft and marry it to some wheels. Take the wings off, turn it into some kind of like a race car with an airplane fuselage as the body. And it's been done, and it's been done in very cool fashion by a number of model makers out there, like Haken Gooney and Gil Mondragon, just to name a couple. Now, I decided that if I was going to build one of these crazy things, that I wanted it to have a story. I had in my head that this would be, I wanted to use a Spitfire because I wanted something that I hadn't seen before. And I basically wanted it to be the scenario that it's like 1955 in a post-nuclear dystopian wasteland of Europe where, basically people are just cobbling stuff together. And the second thing that I wanted to do was make it where it looked like it would actually work. In other words, scratch my engineering itch and make it as mechanically feasible as possible. Because, quite frankly, some of the ones that are out there are really cool looking, but they basically just have wheels stuck on the side of a fuselage. And as awesome as they look, because of my engineering weirdness, can't help but look at it and go, but how does it actually get power to those wheels? So, for my own project, and here it is, this is the Revell 132nd Spitfire, the new tool one from Germany, and it's mated to the AFV Club AEC Matador gun truck chassis. Now, one of my challenges was, like I was just saying, how am I going to get power to the front wheels? And I decided that I was going to need a transfer case that basically came off the front end here, dropped down, and let me run a drive shaft back to the front of the Matador's transmission. So, I had a plan, but I didn't have any parts. And so I decided that rather than scratch building the parts myself, that I would do some 3D printing. I'd done that before, and some of you guys may recall that I've said several times over the course of these videos that I have a mechanical engineering background. And more specifically, that my master's thesis was in product development using 3D printing 20 years ago. So I was on the bleeding edge of this stuff. And actually, the first job I had after grad school was for one of the companies that pioneered selective laser sintering, which I'll explain in a second. Anyway, not to get too far ahead of myself. Point being is, I know how 3D printing works, and I've got pretty solid CAD skills from my engineering days, even though they're a bit rusty. So, there's been a couple of situations in the past where I've decided to use 3D printing to create some parts for a model. And I decided this was the perfect time to do that again. So, thanks to a little bit of help from my buddy George Taylor, who does a lot of this stuff, I decided to try out Rhino, which is a fantastic 3D CAD package. Although I shouldn't really say it's a CAD package, because unlike true engineering CAD software like SolidWorks or Pro Engineer, Rhino is more geared towards 3D surfacing and not so much things that are constrained. And that was a little bit weird to work with it, but I was able to get through the learning curve using some tutorials. And thankfully, the trial version is good for about 90 days. So I proceeded to design myself a little transfer case and some U-joints for the drive shaft that I was going to need. Then it came time to select a 3D printing process. And so with this part of this review, I'm going to give you guys a little bit of background on 3D printing, just a little bit of a primer. And that will tell you not only a little bit about it, but also how I selected the technology that I did. Basically, there are three major technologies for 3D printing: selective laser sintering, fused deposition modeling, and stereolithography. Now, selective laser sintering basically uses powdered thermoplastics like nylon, acrylics, other things that will melt. That's what a thermoplastic is. And it selectively melts the material layer by layer and with a laser, and the heat from the laser fuses the particles together and to the layer underneath. And that's basically the way that all 3D printing technologies work, is they create the part layer by layer. And that has some advantages and some disadvantages, as we'll see. But the cool thing about selective laser sintering is that it produces parts out of real materials, real plastics. And nowadays, with the advent of better lasers and better controllers, even actual metals. So you'll see people producing aircraft parts, guns, things, all sorts of things that are actual metal parts. Now it has its limitations, and we'll talk about that in a second, but basically that's the thing with selective laser sintering. It produces really good works-like parts, but it doesn't have necessarily the resolution and the detail capability that some of the other technologies do, and I'll explain that. The second method is fused deposition modeling, and this is where you see a lot of the inexpensive home type 3D printers that you can get for $500 or $1,000. Whereas a selective laser sintering machine has to run in a controlled laboratory condition, and you will spend upwards of $1 million to get one and set one up. Fused deposition modeling, because of the way it works, really makes things a lot cheaper. And the way that FDM works is basically it just squirts a filament of molten plastic out of a very small print head that it moves around, kind of like a CNC mill would, for example. And it builds that material up layer by layer until you have your finished part. Again, it produces a really nice works-like part in a real material in that it's an actual thermoplastic, but it also suffers a little bit in the detail and resolution capability. So, for me, the natural choice, given that I wanted some really well-made parts that were going to be really small, was the third method, and that is stereolithography. Now, the way that stereolithography works is a little bit different. It works within a vat of material to create the part, but unlike selective laser sintering, where that material is a dry powder, with stereolithography, the material is a liquid, and it's in fact a thermoset. It's a resin. What a thermoset does is it cures because of a chemical reaction, basically. It's called cross-linking. Now, in stereolithography, what causes that chemical reaction to occur, once again, is the heat or the UV wavelength of a laser beam. And because of the nature of the resins that are available for stereolithography, it enables you to get down to very, very thin layers, and that enables you to create very fine detail and a very good surface finish. So, for me, the obvious choice was stereolithography. Now, if you want stereolithography parts, there's a pretty popular service bureau in the United States that I've actually used before, and that's called Shapeways. Shapeways is a great system. Basically, if you're a consumer and you want to get a part made, they not only have tons and tons of parts available in their library, but they have a pretty good system for allowing you to upload parts and have your own stuff produced. But in the past, my experience has been that the surface finish of the parts that I got from them wasn't really quite what I was going to want for these parts. So enter a company called reedoak Rubber Composites, which is in France. Now, you pretty much have to have been living under a rock not to know about 3D printing, and you have to also be living under the same rock not to have seen some of the pictures floating around on the in the model making community of reedoak's amazing figures that he's been producing. His stereolithography work is fantastic, and it's the only stuff that I've seen that really makes me feel like that it's got the capability of surpassing what we can get out of an injection mold. There's a lot of people who have said that 3D printing is going to take the place of current technology for molding plastic model kits. And I'm here to tell you, as someone who's been acquainted with this technology for the last 20 years, that may be happening in the future, but we're really not that close to it. The fact is that it is impossible with any of the currently available 3D printing technologies to duplicate the surface finish that you're going to get off of a mirror polished injection mold. It's just not possible with the level of technology that we have because it's physical limitation of what you can do with controllers and software, and how small you can get the spot size of a laser versus the power of the laser, the materials themselves, melting points, all those things come into play. But basically they mean that there's a limit to how smooth you can get something that's built layer by layer. Now, having said all of that, and having looked at some of reedoak's figures, I've really been like, okay, this is as close. This is not only as close as we're going to get, but it really is close enough in some respects. And I knew from looking at reedoak's website that he does custom work as well. So I thought, hey, this is perfect. I'm going to create my parts and I'm going to send them off to him and get him to make my parts. And I was not disappointed. He uses a machine that costs about $100,000, and it builds in layers that are, he can build in thinner layers, but he builds in layers that are 0.025 millimeters thick, which is really, really pretty thin. I believe that the machine he uses will go down to about 0.015 millimeters. But he finds that he doesn't have to go that thin to get acceptable quality. So, without at least driving the price way up. Because one thing you have to realize about any layer-based manufacturing technology is that the more layers you create, the longer it takes to produce the part, and that therefore drives the cost. So there's always that sort of balance between the surface quality and the resolution you can get and how much it's going to cost. And I felt like his prices were pretty reasonable. So, with all that said and all that rambling, I'm sure you guys are anxious to actually see the parts, and I've got them right here. So, let's take a look. Okay, first things first. That's the parts that I designed and had him build for me. And I've got them sitting right here. And with my big fat finger in the picture, you can get a pretty good idea of what size parts we're talking about. What I've got here is a couple of ends of, these are actually two halves of a U-joint. And this was the only hitch in the process with reedoak. There was just an oversight on their part in looking at my quote, I guess. And he only sent me one set of U-joints. But I emailed him, and he said, no problem. I'll put them in my next run, and I'll get them out to you as soon as possible. So that was not a big deal. What I'm going to do is I'm going to just use a piece of evergreen tubing to connect the two ends to connect the transfer case to the transmission with these U-joint pieces on each end. Now this transfer case thing, this is a really good look at the level of crispness and surface finish. Hopefully my little video camera will be able to get in here close enough to where you can actually see this, and it'll focus. These parts being neutral gray, it's a little bit of a challenge, but let's see if I can get right in there close. Come on, camera, you can do it. Maybe that's as close as I can get. Anyway, you can see pretty clearly what the surface finish is like. If I get the parts oriented just right so that the lights go in the right direction, you'll be able to see some of the layer lines in there. They really are not bad. I mean, you're probably looking at this thinking that they're not there at all. There are actually a few places where you can see the build lines, but they're not too bad, and a little bit of sanding, if I decide to do it, will take care of those. Now, the other thing that you may be noticing is these odd structures that are sort of poking out here. You can see that little one that's poking out of the side of that boss right there. That's a support structure, and they're also on the bottom here. So basically, this thing was built standing up like so. So just imagine that this thing was sliced into about 1,000 tiny slices that look like the cross-section of that, and built one layer at a time. Now, the reason that you have to have support structures is because when the laser first hits the liquid material, it's not rigid. It takes just a few seconds for that to actually become solid enough for it to support itself. So if you've got an overhang, like I do with this thing, if you look at it from the side, you can see that there are parts that would basically just be hanging out in empty space, or just out in the liquid, and they would sag if you didn't have some kind of a support structure. And so different 3D printing technologies create support structures in different ways, but it's pretty much common to all of them. And in this case, it's the same material as the rest of the part, and basically all I have to do is just clip that off of there, kind of like clipping a part off of a sprue and clipping off the injection molding gates. But there's not a whole lot of it that I've got to deal with there. As you can see, again, hopefully the camera is getting in close enough. This is one thing that's that's difficult when looking at examples on the web where people have had this stuff done, is that the pictures are rarely close enough or of a high enough resolution that you can really get an accurate assessment of the surface finish and the resolution. But I think that picture right there gives you a pretty good idea of what he's capable of. Now let's take a look at the other really cool thing, and that's the figure that I had him make. What he does is he gets reenactors dressed up in costumes, and then he does a full body three-dimensional laser scan and converts that data into a surface file that he can then run through his stereolithography machine. And so not only does he get fantastic detail, but he gets extremely realistic figures, because look, they're real people. I mean, check this guy out. He's an actual dude that's been immortalized in resin. And I think you have to agree that there's a lot of things going on here that just would not be possible with either a traditional resin cast figure and certainly not an injection molded figure. A good example is places like where you've got undercuts, like underneath his elbow. You're certainly not going to get that in one piece with injection molding, because that creates undercuts that you just can't put in tool steel. But it's difficult even sometimes with resin to achieve that level of detail and crispness with undercuts, just simply because you're dealing with having to not only sculpt the figure by hand, but then cast a soft rubber mold around it, and then still be able to peel that off to get the part out. Now with 3D printing, you don't have to do any of that because you're creating the entire part in one shot. And so you remove all of the limitations of both injection molding and resin while still being able to maintain an extremely high level of detail. I don't know if the camera will pick it up or not, but if we can get the angle and the light good enough, you'll be able to see here that there's even a crisp edge around both the top and bottom of his eyelid, which is extremely helpful in painting, obviously. I mean, just look at his ear. It's perfect. So, just very cool. And this is a situation where the surface finish that he's capable of getting is entirely acceptable for this type of part because it's not got the flat surface of a mechanical part like my little transfer case does. And so not only do you not have to have such perfect smoothness, but if you have some of those striations that are visible from the individual layers, they kind of get lost in the noise because you've got all these folds and wrinkles and things like that. So there's nothing really that's going to stand out as being anything like a defect. Okay, so there you go. Super cool, right? These parts are amazing. Again, they are, the mechanical part, my little transfer case, is not quite as good as I would see out of an injection molded part, but I don't have an injection molded part, and I didn't have to scratch build it. So whatever slight amount of surface roughness is there is totally a fair trade for the overall quality of the part and the fact that I didn't, have to go through a bunch of gyrations to make it. I couldn't have made something that looks that good from scratch. I just don't have those skills yet. So for me, that's a huge win. Now let's talk about the price. The figure was 21 euros, I believe, which, depending on where you are, I mean, in the United States, that translates to about 30 bucks, which I think is pretty competitive with other figures. I'm not a figure guy per se, so I don't really know a lot about the pricing there, but it doesn't seem bad to me, especially for what you get. I don't really want to be a figure guy. I want to be able to get a figure together, get it painted, and effectively, and put it into my diorama or my scenic base or whatever without a whole bunch of hassle. I don't really want to be good at assembling figures. I don't really care about that. It's hard enough to paint the damn things. So while I'm sure that some guys will prefer sort of the versatility of a figure that you assemble yourself, and therefore you've got some freedom of choice in how the thing is posed or whatever. That for me, and I'm sure for a lot of guys out there who don't care as much about that having the figure come in one complete piece that you don't have to put together and you can get straight to painting is definitely worth the money, even if it were a little bit more than that 30 bucks. So I think that's a great value. The parts that he built for me, the custom parts, for one transfer case and 4 U-joints was about 50 bucks. He also charges you a one-time fee for each part because he has to design the support structure, and that requires some CAD work on his part. So, but that only happens on the first part. So if you had 10 parts made, for example, you'd only get that support structure design fee on the first one. So the total bill for this was about 105 euros, I think, and it took him about 3 weeks, maybe a month to get them all to me. By his own admission, he was a little bit slower because he'd been super busy, but I wasn't in a big hurry. And they had to come from France, so I didn't object to that too much. I wasn't in a huge hurry. So overall, I'm super pleased, not only with the level of quality that I got, but just the whole experience in general. I'm really happy that I've got some cool parts for my project. I think that reedoak did an excellent job and provided great service. He was super easy to work with, and I can't can't say enough how important that is in a situation like this where you're doing having something custom made. So highly, highly recommended. I don't think 3D printing is going to take over the world tomorrow, but we are pretty damn close. We still have a ways to go before any of us are going to be downloading model kits to our kitchen table and printing them out and building them. I mean, you can do it now, don't get me wrong, but not at the level of surface finish and detail that most of us are after. Is it coming in the future? Yeah, probably, but it's not going to be anytime soon, and it's not going to be that cheap. So I don't think that the guys at Tamiya have to worry anytime soon about being run out of business by 3D printers. However, I hope you will see that it definitely has application for model makers and that it's really not that difficult to do. If you can spend a little bit of time learning how to use some design software, then you can produce your own designs and have these parts built for you just like I did. And hopefully you also got a little bit of an idea, without me going into too much excruciating detail, about how 3D printing works and kind of what the technology is all about. So again, I hope this was useful and informative for you guys, and that you think it's as cool as I do. And as always, I appreciate you watching. Take care. Much love.